So where did we stop in the last lecture? Reflection. Refraction get started. Any questions in reflection? Optical? Yes, I will. Yes, yes. So let's quickly revise what we've done so far, so that because it's long, we are starting up with long gap. So this is chapter 9. So all of you have new book. This is the new textbook. All of you, I think you got it. Only don't do that. So you must have the all the exercises given in this book must be solved. Okay. The questions are of various varieties. So you should know what kind of question is expected, right? And so if you have this book, open page 142, those who have, right? And these questions are also given in volume. If you are lucky, I mean, all of them are not there, but some of them are.
There are the exercises.
The book back exercises are there. The index also are there.
Index also.
So I will. Okay, let me locate. So we'll do a quick revision and then we proceed. It's not always the case actually. Like the index questions. Those questions are not done in this. We have solved examples. There are review questions directly. Okay. So what they are doing is they are discussing questions on page number 142. So TV is textbook. Okay. Yes. Come. I'm doing revision so that everybody comes in. So question 1 is, these are in-text question. In-text. Principal focus. What is principal focus? Of concave. Now in diagrams I have told you, now if a question comes like this, what is a principal focus of a concave mirror? You won't get it in volume. You have to have a textbook. So volume, use it while reading just before F. Okay. But when you are learning it for the first time, my advice is you follow the text. Good for concept clarity, etc. Okay. Volume is more like a notes, it's more like a summary. Okay. So what is principal focus of concave mirror? Who would like to answer? Yes.
Principal focus of concave mirror is the point on the principal focus where the
principal focus is the point on the principal axis.
Yes, where the reflected light rays meet at a point.
Which reflected rays?
Which meet after reflection.
Parallel. Okay, so these things should come. So this is the thing. In the diagram you know, but when you are asked to write, then there is a confusion. So you'll have to practice. So what key point should come? Like it is a point on principal axis where the incident parallel rays meet, or you can say converge, after reflection. Okay, so you might know it, but you should also be able to express it. Second question. The radius of curvature of a spherical mirror is 20 centimeters. Okay. What is the focal length? Come. So we are doing revisions for mirrors, right? Yes, who will answer? Would you like to answer? Radius. See the diagram. Half of it, correct. So what is it? 10. It's not even few weeks. It's going out. Okay, so practice and taking tests regularly is a must. Okay. So 20 divided by 2 is equal to 10 centimeters. Shall we give a sign here? Not necessary, because there is no information about mirror. It just says spherical mirror. So could be plus or minus 10, but not required to mention the sign here. Question number 3. What is it? What's question 3? Name the mirror that can give an erect and enlarged image of an object. Of an object. Is produced by which mirror?
Convex mirror.
Convex mirror. Who said that? How many for convex? See, convex always produces diminished. Always. Okay? So this is what you have to remember. Convex में क्या होता है? Virtual and upright always. When the object at infinity, then it is highly diminished. And between infinity and pole, then what happens? Image between focus and pole behind the mirror. So it is always small. Now answer. Concave. What remains is concave. Because concave mirror gives you all kinds of images. Diminished, same size, and magnified. Highly diminished, same size, magnified. Magnified in case of both real as well as virtual. So concave, and on the lens side, it is convex. The role reverses. So whatever is the type of images you got in concave mirror, same images will get in convex lens. Okay, so that's very interesting. So anyway, so it is given by concave mirror. What the answer? You got the answer for this? Direct and enlarged image, because the image in case of convex is erect, but it is never enlarged. So this is possible only in case of concave. Question number 4. Why do we prefer a convex mirror as rear view mirror in vehicles? Is preferred as rear view mirror. Why? So this is a convex mirror. Gets a wider viewing area. Okay. So 2 reasons. One is shows upright images, upright or erect images. Second, offers wider viewing area. Okay. So these are the 2 reasons. So you probably know the answers, but unless you have practiced answering them, right, it is a bit difficult. So we have covered sign conventions in detail.
Yes.
Right? And we had started refraction of light as well. Till where we had completed refraction of light? To be the yes, we've already done the bending of light when it enters from 1, 2. Okay, so we'll start with refraction of light, and I'll cover the optical density while discussing refraction. All right. So this is again little bit of revision. So what is refraction of light? Can somebody tell me, raise your hands, who would like to answer? Because this we have already covered. You try.
So when a light passes from one transparent medium to another transparent medium, the direction of the light changes
In which medium?
in the second.
Correct. So always remember that. The direction of light changes in the second medium. So the medium in which the direction of light is changed is called refracting medium. Okay. So always the second medium is the refracting. Okay. Now the direction changes. How it changes? It goes towards the normal or it goes away from the normal? Yes? Who will tell?
Travels for some medium, then it moves towards the normal.
Correct.
And when it moves through a less denser medium, then it moves away from.
No, you said the same thing.
And
When it enters the rarer medium from the denser medium, then it moves away from the normal. We had written these things. So what is denser or what is rarer? It is about optical density. See, generally, we define the mass density as how? What is mass density? When we just say density, okay, of any object, we refer to its mass density. What is mass density? It is density is always mass of the substance upon volume. So mass per unit volume is the density. So if you have a substance which has less mass for a given unit volume, it will be less dense, right? So density basically, what does it signify? It signifies the heaviness. How much matter is condensed in a given volume. So one unit volume is 1 meter cube. In a CGS scale, it is a centimeter cube, let us say. So let us say if you have a substance with 1 kg per meter cube, right? So you have a 1 meter box like a cotton. So in 1 meter cube, a cotton could occupy whole meter cube and it could be just 1 kg. Now, if we just stuff more and more cotton in the same volume, then that package, the other package will be more heavier. So it will be more denser. So that's why a cotton bag of volume 1 meter cube will be much lighter with respect to a metal iron 1 meter cube. It will be like, it will run into many tons. It won't be kg then. Okay. So density basically differentiates among substances in terms of their heaviness or how much matter is condensed in a given volume. So meter cube is a very big. So if you talk about gram per centimeter cube, this is much easy to compare from thinking. So 1 centimeter cube is how much? 1 centimeter by 1 centimeter by 1 centimeter, right? So just make a cube of this. Is this 1 centimeter? It's much bigger. Imagine this is 1 centimeter. Okay. Let's say you have a container 1 centimeter by 1 centimeter by 1 centimeter. So if you have say water, you have honey, right? You have milk. Fill the same container with same amount, whatever it is, okay? You will see that it will weigh different. Right? So why it will weigh different? Because mass is, so density is equal to mass upon volume, which means mass is equal to density times volume. Volume is constant. So mass will be proportional to density. You understand? So you're going to use this relation a lot in chemistry. So once the volume is fixed, the mass of the substance will depend upon the density. That's a more fundamental thing to compare the weights. Okay? And then the weight will be just multiply that by G. Got it? That is about mass density. Now what about optical density? So optical density is different than the mass density. What is optical density? A substance mass density may be heavier. Listen carefully, but its optical density may not be. Optically dense substance, inside that the speed of light reduces. How do we define optical density? Those substance in which the speed of light reduces, they are more denser than those substance in which the speed of light reduces less. Is it clear? So it is very different than mass density. So what is optical density? Let me write down. Optical density of a substance determines reduction of speed of light okay. It is not same as mass density. Have I answered your question? No. Hey, what's bothering you?
No optical density. Sorry. The optical, there are optical display.
This is optically denser. Second one. That's why the speed got reduced in the second medium. And when the speed is reduced, then it shifts towards the norm. So there is a difference between the optical density now. The optical density of air, is it less or more than glass? What is the optical density of air as compared to optical density of glass? Less or more? Ah. Which is denser? Second medium is denser. So it is optically denser.
Like the speed reduces.
Yes, only when the speed reduces, it is turning towards the norm. If it enters and speed increases, then it will suddenly go away. Now, when it enters, the speed reduces, therefore it turns towards the norm. Is it clear? So the description is given in your textbook in the yellow box. Somewhere here. Okay, but these things are not asked in exam. Not for exam purpose, but you must know. So this is one of the reasons why the bending of light takes place. Okay. Do I need to get into this level of discussion? Huh? Too much, right? It's already causing you to sleep. Huh? Okay. So are you now clear what is optical density? How many of you are planning to take up science after 10? Raise your hands. Science. Now I know why no, sir. So all of you who are planning to take up science, better start liking this kind of discussions. Okay? Yeah. And those who are perfectly all right. So just put up for this year. Right? All right. So quickly. So we had two mediums, 1 and 2. So first thing you will do is you need to have, when you are studying refraction of light, you need to have two mediums. Okay? One of them will be air, other will be glass or water. Glass or water, both are denser with respect to air, and this is rarer. Okay? So as long as you wear specs, watch television, right? And travel through sea, right? Do swimming. You must know, understand what is refraction. All of you who are using glasses, okay? So it's good because it is general. So till 10th it is general science. And let's call this AV as the surface, or this is the boundary between the two mediums. Okay, so far so good. Third thing you will do is you will draw the normal. Okay, so what is it? Normal. And this is, let's call it a O. Right? This is N dash and this is N. If now a light falls at point O, let us say, so this is what kind of light? Oblique, making an angle with the surface, right? So it is not parallel to the surface. It is not normal to the surface. It is oblique, right? Oblique. Obliquely. When the light is incident on a surface, obliquely. Then whatever angle it makes with the normal is called angle of incidency. Now in the second medium, its direction is going to change. So what is the original direction? This was the original direction. Right? But now it is a denser medium. So where will it go? Towards the north. Very good. This is your refracted ray. Let's call this as PQ. Okay. So this angle is the angle of refraction. Till here we have discussed. Now let's go further. There is something called as laws of refraction. right? Laws of refraction. So what are these laws? There are two laws. First is the incident ray, the refracted ray, and the normal lie in the same plane at the point of incidence. So same as law of reflection, the incident ray, the refracted ray, and the normal at the point of incidence lie in the same plane. Okay, this is the first law of reflection. Second law is known as Snell's law. Okay, second part of this law is Snell's law. What it says is the ratio of sine of angle of incidence to the sine of angle of refraction is constant. Okay, this is the second law. And this constant is called refractive index.
What is the measure of sine?
Wait, the refractive index. Right? And how is it represented? That is sine of I upon sine of R is equal to, it is written like this, n21 or n21 like this. Where? How do we read it? N 1, 2, 4, and 2, 1 is red. Is the refractive index. The short form is Ri of second medium with respect to first medium. Okay. What is it? So whenever you take the ratio of sine of angle of incidence to the sine of angle of refraction, you'll always get a same value for a given pair of medium. What is the pair of medium in this case? Pair plus. Okay. Next day.
First one.
This is same as law of reflection.
Like when I'm not representing the normal at the point of incidence.
Point of incidence is O. Where is the normal? Where is the incident ray? They're all falling at O. That's the point of. And it was same in reflection also. So just to give you an example, in case of reflection, this AB was, this is AB, for example. And now this is the normal. So during reflection, the normal doesn't cross the other side because there's no ray going beyond, right? Same situation. You have angle of incidence, then the reflection happens in the same medium, right? Is this R and this R same? No. What is this R?
Refraction.
Angle of reflection. And what was the law here? Angle I is equal to angle R. What is the law here? Do we have I equal to R? No. We have the ratio sin I by sin R. That is constant. When is it constant? For a given pair of waves. What does it mean? It means if I now change the angle, let us say I increase the angle. Let's say now the ray is incident along this. So now I have a different angle of incidence, right? So then it will have a different angle of refraction, right? Now if I take, let us say I call it I2, this as R2, right? So now if I take sin I2 by sin R2, I'll get the same value as the previous one. As long as this medium is air and this medium is glass. So when you change the angle of incidence, the angle of refraction changes proportionately such that this ratio is always constant for a given medium. Is it clear? So that's what it is. So for air and glass, this ratio is found to be for air and glass. And 1 is equal to 1.5. हमेशा क्या मिलता है? 1.5. Okay, for air and water. And 1 is equal to 1.8. ये समझ आ गया? So these are experimentally found values. Any questions still here? So now you know how to read this refractive index of second medium with respect to first. This also refractive index of second medium with respect to first. This is just to separate the two medium, the incident medium and the refracting medium. Some people have confusion learning this, okay, but this is the most standard notation. हमेशा refractive index किसका होता है? Second medium का, इसके लिए उसको पहले लिखो with respect to first. Okay, so either ways, right? So no need to draw the red line. If you have understood one, it is good enough. Shall I erase left side? Any questions, anybody, please feel free to ask. But this is important, one formula for refractive index. So refractive index is also defined so I have just written the mathematical equation. Can you write the English yourself? How will you write the English? That's important, right? So in English, you will write that refractive index is defined as the ratio of sine of angle of incidence to the sine of angle of refraction. ठीक है? Ratio. You can write, depends on the question. What is in the question? You have to write the kahani or just the expression. So now, how many of you feel maths is easy now? Isn't it easy? And English is always a bit challenging. So maths simplifies things. So it's a myth. Maths में दो लाइन में काम खत्म. Now you write paragraph.
ये पूरा लिखना पड़ता है
हाँ।
उसमें तो कुछ भी नहीं।
ये समझ आ गया? तो बचपन से लोग जो भागते थे दूर मैथ्स से, उनको मैथ्स से दूर नहीं भागना चाहिए. मैथ्स अपना दोस्त है. ये तो लिखते जाओ और अभी और आधा पैरा लिखना पड़ेगा. समझ आ गया? So one motivation to be more maths friendly. Okay. So RI is defined as what is RI? Refractive index is defined as the ratio of sine of angle of incidence to the sine of angle of refraction, and the story is not completed. What's remaining? And it is always constant for a given pair of medium. Okay. Which is, I'm writing here now. Which is always constant for a given pair of अब जाके
A ratio of what?
Sine, SINE. Sine full form is SINE. Short form is SIN. You studied trigonometry, right?
No.
Not yet?
No, sir.
Okay. That's why she. Okay, I'll explain what it is. So a lot of job of maths, I am actually making it easy for him, right? So physics begins where mathematics. No, not like that. It goes hand in hand. So it's like saying, okay, mom is more important than pa. It's not that. It's that kind of comparison. So we go together. Right? But there are people who like to, differentiate. So that's an difference. So are we good till here? So this is one definition of refractive index. The other definition is also defined as ratio of speed of light the incident medium to the speed of light in the refracting medium. Okay, so incident medium में तुम बोल सकते हो V1, and refracting medium में you can call the speed of light as V2. Therefore, V2. Okay, so these are the two definitions of refractive index.
So V1 and V2 are mediums.
Speed of light in the incident medium V1. Speed of light in the refracting medium is V2. Written in the. Okay. So these are the two definitions of refractive index. Now there is one more. Okay, can you tell me what is the speed of light in air or vacuum? 3 into 10 raised to 8. It's special, and I had said that it is constant, right? What is its symbol? C. Very good. So or R I. If the first medium is air, right? Then U1 is equal to C, right? The speed of light. Air or vacuum. So speed of light in air or vacuum is taken as C. And V2 we just write as V. Okay. So C and V, these are, what is V2? V2 is the speed of light in second medium. Right. So therefore, what can we write? N2 1 is equal to equal to CY. We don't mention the first medium in that case. Okay, we don't mention the first medium. If the first medium has air. Now we call this N2 as absolute refractive index. Right. Where N2 is called absolute refractive index. Second medium. So what is the meaning of absolute? It means refractive index of the medium, like glass or water. When we just say refractive index of glass, it means with respect to air. Okay, so maybe we will not even mention two then, because we know what is the refractive medium, or just refractive index N, right? So for now we will keep N2. Later on, when you become more familiar, then we'll drop 2 also. Is it clear? So let it sink in. So too many terms right now, I understand. So you have any questions still here? Just note down everything. Take a look. You can ask. Very amusing, huh? Refractive index. Good. As long as you don't sleep, I'm over it. How many of you had good sleep tonight? He is the only one. What were you doing? Playing games? Okay, good. So this being the first day, what is your school time? I think you're used to waking up at this hour, right? Okay. When is your school? What's your school? 6:32. Come on, we started 1 hour later.
8 to 3.
8 to 3. So which school is 6:30? You have to be in the school premises at 6:30.
Yes, sir.
How many for the nights here? Yes, sir. Take it, sir. So for rest of you, is it a torture? Huh? No, it's not. 7:30 is pretty late. We should get up somewhere around 4:35. That
Yes, we can open up at 5. We are cycling at 6. That's
have you not, like in your early days, studied that poem early to rise and early to sleep, something like that? Makes very clear for exam basket again. Whatever we are teaching you, you're going to use it in your life. Some of it you have to using, but now you're discovering how it works.
मैम ने सिखाया था पूरा
So the thing is, आया था एग्जाम पास करने के लिए नहीं, वो तो है ही. But basically to imbibe those things in your life, become more informed citizens or human species. It's all about raising your awareness level so that you can live life in a better way and make others' life also better, not heavy. Education is for that, right? Rest is consequence. You become a good guy, bad guy. Everything is a consequence of what education has gone inside. Can you explain what? Snell is the name of a person. He first gave this. So he first gave this relation after studying. Okay. So he did experiments and then he realized that the sign of I versus sign of R is always constant. Okay, so little bit of introduction to sign what it is. Okay, let me tell you. Can I erase this side or this side? Erase either side? Yes, sir. Okay. So we just put a line, okay? This is mathematics. So ratios of right angle. This symbol you understand?
Yes, sir.
Right angle. Okay, let me write angle. Right angle triangle. Okay, so trigonometry is very specifically about ratios of sides of triangle. Okay, so if you take this triangle, so what are the name? This is called base, right? This is perpendicular. The side opposite to angle, right? Is called perpendicular. Okay, and side opposite to 90 degrees called hypotenuse. So you know all this, right? Now, what is sine? Sine is defined as, what is sine? Perpendicular upon hypotenuse. E by x. This ratio of a right angle triangle is named as sine. Sine is a ratio. ठीक है? ये समझ आ गया? Okay. What is cos?
Based upon hypotenuse.
Yes. Cos is based upon hypotenuse. Let's call this as B. This is B. This as H. Okay. So it is based upon hypotenuse. Right? And tan is perpendicular upon base. That's it. इतना ही सब इससे आया है. तो इसका जो रेसिप्रोकल है 1 upon sine is cosine, not cosine, cosec, right? So cosec will be h upon p, reciprocal. ठीक है? What is cos? Sec. 1 upon cos is sec. And what it will be? Okay, so if you remember these three, then tan is cot. Now these are short forms, right? So this is called sine, S-I-N-E. This is cosecant. So what you are seeing is the short forms. This is cosine. Okay, and this is secant. Secant, okay, and this is tangent. And this is cotangent. So don't get too much bugged by this. These are very simple actually. Just when you hear it for the first time and when there is a theta attached, then you go wild. It's very simple. So what is theta? So here this theta is in the form of angle of incidence and angle of refraction. Then there are certain values which you will learn how to figure out. So there are some standard values. Let's say theta is equal to 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. So you remember sine theta. So sine value changes from 0 to 1 value. Degree is, so sine 0 is 0, sine 90 is 1, and everything will be in between. Okay. So what is sine 45? 1 upon 2. Right? 1 upon, this is 1 upon 2. This is root 2. Root 3 by 2. This is how it is. बस इतना ही याद करना है और वो हो जाता है. तो देखो, every value on the left is smaller than the value on the right. It is gradually increasing up to 1. So cos, once you remember sine, then what is cos? Opposite. So 1 root 3 by 2. This remains same. 1 by 2, 0. Then what is tan? If you do sine by cos, right? So you will get p by e. Right? Multiply and divide by h. You get, so tan is basically nothing but sine upon cos. So just do sine by cos, so that value you will get tan theta. This is 0, 0 by 1. Just draw one line. This is root 3. What about this? 1. What about this? Ulta ho gaya. This would have been 1 upon root 3. Root 3. This is infinite. You are not defined, right? 1 by 0. So don't break your head in remembering these values now, but this is the basis of what is sine, cosine. These are basically ratios of sides of right angle triangle. That's it. Okay. So maths is a tool to learn physics. It's like hammer and chisel. What is physics? All these buildings. Okay. So what comes out, the end result, that is physics. So maths is a tool used in various things. Okay. But what is the end result you want? For that you need physics and chemistry and biology. So maths is required everywhere. That's why if you are intending to become doctors, if you are a good mathematician, then that makes you that much more better doctor. Because you have the reports in front of you. How do you draw a conclusion? What mix of medicines to be given? So without mathematics, others are no good. Okay? You are as good as how expert you are in using your tools. So maths is one of them. Right? But no point in having a heap of so much tools that you don't know how to use them. So the rules to use, so everything is very important. So physics will tell you how to basically use the tool effectively to get the end product the way you want. So it's, you can't do without the other, okay? Together. And it is applicable in life also. Like country thinks, oh, I'm a North Indian, right? Somebody says I'm a South Indian. They say, oh, East. Nahi chalta hai. You need to be together. Otherwise, there's somebody waiting to snap you, right? Chinese, Pakis, okay? So when you're together, then we just kick them like a football. But when you're scattered, gone. So togetherness is very important. So is maths our friend or foe? Who said that? Who said that? Friend or foe? Somebody said both.
Best.
So best friend. Who said that? Very good. It can only be a best friend. There's nothing else it can be. Okay. Chalo. Erase it. Erase it. Somebody लिख दिया? All right. Next is, so we actually did a topic ahead, right? And if your book, you can see refractive index of various substances. Can you see? Now, what does these values mean? It might be given in the volume also. Just check. Is there a table of refractive index in the?
Yes, sir.
It's there, right?
Page
So,
number 33.
page number
Yes, sir.
2 में होगा ये.
Yes, sir. 1.
Which page number you said? 33. I am having the old volume of one. So look at these values. For air, it is 1 almost. So taking air as 1. For all other, the refractive index is more. So higher the refractive index, that much more it is going to bend the ray towards the north. Understand? So high value of refractive index means the bending ability of the second medium. Okay, so you will see which is the most highest refractive index, sapphire. Right? Diamond 2.42. Yes. So diamond is the medium with the maximum refractive index. Right? Least is air. Okay. Is there any medium less than air?
No.
No. So that is the reference. So if light comes out from glass to air, then what will happen? It will go away. Right? If it enters from air to any of these mediums, it will go towards us. Is it clear? All right. Now look at the refractive index of, now to understand optical density. Look at kerosene and water. What is the refractive index of water? 1.33. Whereas what is the refractive index of kerosene? 1 point. So optically kerosene is more denser than water. But in reality, if you see the density, mass density of kerosene, it is lighter than water. Isn't it? Now this generation doesn't know. I mean, you have not played with kerosene, right? Have you seen kerosene? Smelled it?
Yes.
Where did you see it? Where? Villages? Villages, right? Or does anyone have this camping for camping? Do you carry kerosene stoves? Have you seen kerosene stoves? Great. So it will be found only in villages, and if you happen to go to villages, you might see. So if you take a glass of water, right? Put some kerosene in it. What will you see? It will float on top. Like oil, right? It is kerosene. Daily bolte na usko. So it is a crude oil, right? Or refined little bit. So it will float. What substance can float on the surface of water which are lighter, less dense than water? So mass density of kerosene is less, but its optical density is higher. Are you with me? Optical density of kerosene is higher, not its mass density. Okay, is it clear? All right. Now we have so many questions. 5 questions are there, right? And before that, I would like to cover. Yes. Any question? Okay. Before that, we will study refraction through a glass slab, rectangular glass slab, which was before this one. Refraction of light. glass level. That's a rectangle. Rectangular. Okay, in real life, let's get some examples from real life of refraction of light. Have you, let's say there is a bucket full of water and you put your hand in it, or scale, for example. You see the scale is bent.
Yeah.
Have you seen it?
Yes, sir.
When did you have the opportunity to put a scale in water? How many of you have seen? Anything you put in water, its shape changes, right?
Yes, sir.
So why? If you put a stick, okay, see what happens is, देखो, let's say you have let us say this is a stick, right? So what happens to it? The portion which is underwater, what happens to it? Yes. So what happens is it will bend upwards like this. It doesn't remain there. It bends upwards.
The bends downwards towards the tensor.
When you go near a swimming pool, right? And you look at it like this. Do you find it deeper or shallower when it is full of water? Shallower. When the floor has come up, you feel that the water is less than it actually is. In my childhood, I made that I jumped. And I don't know swimming, even today I don't know. Only lucky to survive. Don't do this stunt. If you don't know swimming, when you will go to a swimming pool, which is say 8 feet or 10 feet deep, okay, even 8 feet is sufficient because in panic you forget even how to jump off. So don't, if you are not a trained swimmer, do not do this stunt. You will feel okay, it's very less. The depth will be, it will look shallow. That's why the stick, instead of going down, you will see the stick is bent upwards. Okay, this is the application of refraction of light. So it is very important for you to know the theory of refraction of light to survive. Okay, so take physics seriously. You have electricity, everything is coming down. Therefore, what happens? Now, what case is this? Is it the case of light traveling from rarer to denser or denser to rarer? Denser to rarer, right? So this stick is there in its position, but how it appears to you is like this. Okay, so what happens is, they go. So one, we have to take two rays for image formation, right? So देखो, ये वाले से एक normal बना देगा इसको. This is a tip. So one ray, let's say, is going along the normal, right? It goes along the normal. Will there be any refraction? No, because it will just pass undeviated. Normal is an exception everywhere. Either whether it is reflection or refraction, right? There will be no change, no deviation. And the second ray we are taking, let us say this ray. Slightly away. And we draw the normal here. Okay. So now it will not go straight, it will go like this. Away from the normal. Correct? So where is the image now? extend backwards. This is the point. So an observer here feels that where are the rays diverging from? This point, right? So the virtual image of this actual stick is forming above. You understand? Okay. So this is how it is. This ray will not be there.
So,
Yes. Yes. This is for this point. Now the same two rays from here and here, and this stick will be reconstructed like this. You got the reason how it is bending upwards? No? What did I say? How you see things when the light falling on the, how you see this pen? The light is reaching your eyes, right? So how the light is reaching from the lower portion of the stick, which is actual stick here. So when it comes out from the water surface, this is a denser water. In this case, light coming from this stick to outside. So it is which case? Denser to rarer. So when it comes out of the water surface, it will go away from the normal, correct? So this is one ray and one ray is along the normal. Now you understood? So once this ray comes out, so what the observer will feel from where these rays are coming out? He will feel that the ray is coming out from this point, not this. Okay, so he will feel that the object is here. That's why you feel that the depth of the swimming pool has raised upward. It is because of this. Now, okay. Reluctantly, okay. It will take little while when you study more ray diagrams. Is it clear? So I'm giving you this so that you have some motivation why to study refractive index. It's very important. So you may draw this diagram on the sidelines, but what we are going to study now is refraction of light through a rectangular glass. Okay, let me suggest you an experiment that you can do at your home as well. Take a utensil, right? Put a coin in it. Because of what I'm trying to say. Take a utensil, maybe a ball with a wider mouth. Let's say this kind of a ball if you have Chinese soup bowl. Soup bowl, okay. Let us say Chinese. Okay. So at a country level, we will, hate them, but at a global cosmic level, we love them. They're brothers. Planet Earth. We occupy the same planet. So when it hampers our interest, not allowed. But when we're dealing with aliens, we need them, right? So Chinese bowl for this experimental purpose. Put a coin, right? So you've kept a ball. Now you can see the coin. Raise the height. Raise the height. There will be a moment the coin will disappear. Means you will not be able to see it. This boundary will block it. Okay. So at this level, first when the coin disappears, hold there, right? Now start pouring water in it. You will see that the coin is visible to you at the same level. Did you get the experiment? You are keeping the ball over here with the coin. Now you can see because you place the coin, right? Now you raise the ball. The edges of the ball now will block it because now it is not in direct line of sight because coin is at the base. Okay. So either you keep the ball, you start sitting down, whatever. Okay. Now coin is not visible to you, right? Because it is at the base. You start pouring water in it. So when you start pouring water in it, you will see at the same position now the coin is visible. Do that experiment and share with me the next class. Okay.
how the rays gone.
Here or here? Okay. This is the stick, right? This much portion is inside water. So when you are seeing it from outside, this stick is visible to you and you can see there is some bending for the stick which is inside the water. It bends upwards, right? So how do you explain that? Why it bends upwards is, let's take this as a dot, and for image formation, right? 2 rays are needed at least. So one ray I'm taking along the normal, so it will go straight. The other ray goes till the water, and then when it comes out, it will deviate away from the normal, because at every point I can draw normal. Wherever is the boundary, I can draw normal at every point, right? So one normal here, one normal here. For another ray, it will go even further. Again, after extending backwards, so I can draw normal anywhere I want. Okay, infinite rays are possible, but I am taking only 2. So as an observer, what will I feel when I see these rays? I will feel that these rays are coming from here. So this scale point is constructed, is observed by me at this point. Likewise, I can choose another point and then repeat the same diagram. So I will get the next point, this point over here. This point will appear to me from here, like that. Okay, so this is how it is done. So it's a repetition. Becoming alive. Physics is becoming alive now. Only with the help of experiments, not when you read it for the purpose of clearing exams. Then it is boring. But when you understand it, then it becomes part of it.
Actually doing it more.
Yeah, and actually you're not doing a favor, When you do physics, where is it? It's in you. You are understanding how you see things, how you work. It's about you. So if you know yourself better, right, you can use yourself better. So knowing yourself, it's not like you're doing a favor, right? You're just letting you know how better you are. That's it. So you have physics in you, you have chemistry in you, you have bio in you, mathematics. You can't paisa, right? So सब तो तुम्हारे लिए अंदर ही है, तो ये कुछ burden नहीं है. You are just uncovering your own potential, right? That's about it. So once you know the purpose, the motivation comes, right? Who doesn't want to know what package are you? Right? If you know what are you, then you can take corrective steps or not to take steps. Okay. All right. Can I erase this now?
Yes, sir.
Yeah. Having understood all that, how much more time we have before the break? In 15 minutes. We'll finish it. So let us say you have a rectangular slab. This is also an experiment, right? This is your notebook page. The board is your notebook page. You have kept a rectangular slab in your notebook, right? And drawn a boundary around it. What have you done? Boundary. एक rectangular slab रखा है और उसको edges में ऐसा boundary बना दिया. Now I'm naming it. Let's say ABC. ठीक है. So like this. So how will you see it? You'll see it like this. Imagine this is a perfect cuboid. Okay. So the base will be a rectangle like this. Now what we are doing is, so there are two sides. One side of the cube is towards you and one is towards me, right? So this side is the back side of the rectangular slab and this is the front side. What you are doing is, on this side, you are now inserting. So it is on the chart paper and you have drawn this. Here you are inserting 2 pins. What have you done? 1 pin here and 1 pin here. And now you are trying to see those pins from this side. Okay. So you are trying to see the pins from. Okay. Got it. So 2 pins you have inserted and you're trying to see it from this side. Okay, this is what we are doing. So let's do it. So let's say 1 pin is over here and 1 pin is over here. Right? Let's call this as P1 and P2. Okay. Now what you're doing is join. So these are the points where the pins were inserted. Now what you will do, you will just join these two so that it hits the slab at O. That's it. So on the chart paper, what you're doing is you are marking a normal. Okay. Then what you will do is, this is will not do. देखो, यहाँ पे when you see these pins, let's say you see two pins like this. That's it. Okay. Now when you see it from this side, you take a pin in your hand and try to align it. So when you see, so this pin should hide it. You should not see two different pins when you are looking from this side. So when these are aligned, okay, try to insert another pin such that it is in the, they all look in the same line. And one more, right? So as an observer, only see the last one. I hope you're getting it. You will insert more pins like this. This is how you will find. Okay. So when you watch it from this side, such that you only see now this pin. So one by one you are, inserting the pin on the drawing board. Okay. So you will get two more pin positions, right? So you find that you get a pin over here and another pin over here, like this. Let's call this as P3 and P4. Right? So when you join it, you find it that the pins are like this. Okay. So what do you see? When you take the slab out and the pin out, you then draw this line. So what do you see? Okay. Although you saw everything straight physically, but basically what do you achieve? You get this kind of a thing. How this could have been possible? This could have been possible because there is a refraction took place here. Let's call this as angle of incidence. This is angle of refraction over here. And then when you draw the normal here as well, there is another refraction over here that you're calling R2. Right? And what do you call this point as? P3 minus P4. What is this? You will call this as E, angle of emergence. Okay? So let's write down first. So I is angle of incidence, R1 and R2. Angle of, yes, refraction. Yeah, hold on. E is angle of emergence. Now, why did we get a ray diagram like this? See the diagram in the book, just in case you're having difficulty comprehending it. See the nature. I will. So what is happening? So there are two mediums. One 2, and again 1. So 1 is what? Air. This is glass. And this is air again. So refraction is taking place at O and at O dash. 2 points of incidence, right? One is air to glass, second is glass to air. Right? So what do you observe? We observe that the emergent ray is there any deviation between the incident and emergent ray? Is there any deviation? There is no deviation. They are parallel only, no? Yes. It is parallel to incident. So where is the deviation? What is the angle between parallel lines? 0. So no deviation. But there is a lateral shift. They shifted. There is a lateral shift. There is only a lateral shift. There is no deviation. Okay. So this is the observation. So observation of this experiment is the emergent ray is parallel to incident. Okay. So what is the emergent ray? You can say O dash P4. O dash P4 is emergent ray. And what is the incident ray? P10. So you can write it. Incident ray is right. Second, there is no deviation between the incident and emergent. This angle of incidence is equal to angle of emergence. So sometimes there will be a question. Draw the ray diagram for refraction of light through a rectangular glass slab, right? And then explain the inferences or observation. These are the observations. Now, how do we explain this? What are the two surfaces of the glass slab where the refraction is taking place? AB and DC. Right. Now you know that the pair of medium is same here, air glass, and at the second it is glass air. So the refractive index has to be constant, right? The refractive index has to be constant. So the amount by which the ray was bent towards the normal, right? At the time when it is entering the glass, it will go away from the normal when it exits the glass by same amount. Because the refractive index determines the bending. Okay. So bending is same amount at both the surface. Once it is towards the normal, second it is away from the normal. So in the process, what has happened is only the emergent ray got laterally shifted. That's what has happened. But there is no deviation. Deviation meaning difference in the angle, like incidence angle and refracting angle. But refracting is here. But this we call it emergent. So there is no difference between incidence and emergence. Because both are parallel rays. Is it clear?
Yes.
All right. Now you're experts on refractive index of light or refraction of light. So now tell me, what is the physical significance of refractive index? What is the physical significance of refractive index of light? What is the refractive index definition? So what does this mean? B2 is equal to B1 upon right? Speed of light is maximum in first medium, or E is equal to C upon. So refractive index of the medium tells you by what factor the speed of light reduces in the refracting medium. Got it? So refractive index of a medium is the factor by which the speed of light reduces in the refracting medium. Right? See, for example, glass. What that is? When we say refractive index of glass is 1.5, it means refractive index of glass with respect to air. Sometimes it is also written in terms of letters. G for glass, A for air. It is 1.5. So therefore, what is the velocity of light in glass? This is equal to C by NGA. This is 3 into 10 raised to 8 divided by 1.5. Right? So this is how much? 30 by, so 2 into 10 raised to 8 is what you get. So this is the speed of light in glass. Whereas here, you know, it was 3. Okay. So how much it got reduced? 1 by 1.5 times. Okay. So let it sink in. Like these are concepts which will take some time to sink in. It goes slow on this. Sure, you have a big break, huh? 15 minutes. We've been taking only 5 minutes break, right? So enjoy. Yeah. So, any questions before we proceed? Yes. Yeah. Yes, sir. Yes. In the exam. How is it? So it will go away. Oh, for the same situation? Hey, how are you looking? Same again now, where? Do you have compliments? What is this guide? Acha, explain. This is the guide. That's it. Take off the screen. What is that? This is backward. Yes. Half of it is inside. Rest is outside. But price. Okay, so anybody has any doubt before we proceed? Okay, let's proceed. So, what did we do till now? Till now we have done RI is sin of I upon sin of R. Okay, so what is this? This is n to 1. This is what it is. Also, we have n to 1 is equal to B1 upon B2. Right? Then we have n2 is equal to C by B. Okay, so it is equal to n. Sometimes I told you when it is C by V, then the refractive index of the medium. Okay, then we don't mention anything. That means it is the absolute refractive index, or it is the refractive index of the medium itself. So it is one and the same thing. Okay, you'll get to know when the context arrives, right? So you can say or just n. Okay, just n. Now some more relations. So what is, let us say we have this situation. Right, this is 1, this is 2. I and R. Right, so what is N21 in this case? N21 is equal to sine of I upon sine of R. Now what about N12? If we just reverse the direction, same situation. Let us say we make the angle of incidence same as R. And this is now angle of emergence or angle of effect. When we reverse the direction, keeping these angles same. Now what is the, how will you write? Therefore, what is N12, right? What is the second medium now? 1. First medium is 2. Just by changing the direction of light. So what is it now? Sin R by sin I, isn't it? Okay, same rule applied when the direction is reversed. So it becomes like this. So can it be written like this? Can it be written like this? Yes. Therefore, can we write it like this? So this is the relation. Sin 21 is equal to reciprocal of sin 12. Okay, that is all these relations are very useful in solving numericals. Right? So many relations you can just number it. 1, 2, this is 3, this is 4, right? This 4th one. Some more with right now. Also, so multiply and divide by C. This is equal to C. Multiply and divide by. We can do this. Now let's rearrange. This will be C upon V2 into 1 upon 2. C upon V1. Can we do this? Right. So what is this? This is N2 upon 1. These are the relation in terms of absolute refractive index.
How did you do that with 29 points? How did you?
Mathematics allows me to multiply and divide by the same number. So I multiplied and divided by speed of light. Now I use I did rearrangement so that I can use this formula. Okay, the formula for absolute refractive index. Here, this could be confusing. When I say V1, which medium is it? Second medium. This V1 will, so see, for example, you have air, glass, and you can have air, water. Right? So you can have NA, NGA. You can have NGA. You can have N water A. Then you can have NGW. Okay. So when you have glass with respect to water, glass, individual. So what is the relation between all these? Right? What is NGW? So therefore NGW will be is equal to NW by NG. Oh, sorry, ulta ho gaya. NG by NW. That's why number is also required to keep a track of sequence. Always the second medium on top in terms of absolute refractive index. Is it clear?
Yes, sir.
So these kind of questions will, you may be asked to solve numerical in which this will be useful. Okay, so this is your fifth relation. So these 5 relations will be very useful. This is just the example. Is everything written on the board making sense to you? So how do you read the example? Somebody, okay, you, what's the name? Your name. Stand up. Read the example. Is refractive index of glass with respect to air. Next. Yeah, right. Next. Water. Very good. So why are you so scared? I mean, don't be scared. Yes, what's your question?
I was thinking,
So you read the last one.
okay. The refractive index of glass respected to water is
With respect to
with respect to water is equal to refractive index of glass.
absolute refractive index of glass
Refractive of glass in the ratio of
with respect to
with respect to with respect to and with respect to
absolute refractive index of water. Okay, so you'll get used to it. So it's okay, it's all right. Huh? So this is first day in getting familiar with all this. So with this, I think we are through with the basic introduction of refraction of light. Okay. Now we will use this to now learn what. Right. Now that we have learned this far, let's do these questions. There are 5 questions. Okay. So after this, we'll start with ray diagrams of lenses. Which side should I erase? This side? Okay, you write and then give me a go ahead. So try to capture everything which I'm giving you on board. It will make your life easy because book could be pretty lengthy. Too much English. Huh? This is the essence. Was all done writing? Can I erase till the diagram? Okay, the first question is, a ray of light traveling in air enters obliquely into water. Does the light ray bends towards normal or away from the normal? Why? Did you hear the question? Yes. Go.
Bends towards the normal because water is denser.
Very good. Okay. So once the concept understood, easy to answer. Okay. So it was a child's play. First question. Page number is 150 in the new book. If it is the old book, yours is the same. Yours seems to be old book, I think. So it will be like add 30 into it, 180 or somewhere close to that. This topic, reflection by spherical lenses, just before that, 176. Yeah. So the first question is, everybody okay? Whenever the ray of light enters obliquely into water, the light ray will bend towards normal. Why? Because water is optically denser with respect to air. Second question. Light enters from air to glass having refractive index 1.5. So question 2. So 1 you know. Question 2. This is page 150 in text questions. So towards normal. As water is optically denser. Then air. Second, light from air to glass given. So GA is given as 1.5. What is the speed of light in glass? So VG is equal to 1. Okay. Speed of light in vacuum is given C is equal to 3 into 10 raised to 8 meter per second. Meter per second. So we know since G upon speed of light, there are two formulas of refractive index. C and D. Right. C is the speed in air. So therefore, what do you have to find? V. This we have already done. 1.5. So this is 2 into 10 raised to 8. Okay. So this is how you do it. So next is like, can you read the next question? Third one.
Find out from table 10.8 medium having the highest optical density. Also find the medium with the lowest optical density.
See, now we can send this feedback to NCRT. Now this is table 9.3. But question is lifted as it is 10.3. Should be table 9.3. 10.3. No, yours is an old technique, but in the new one, question says table 1.3, 10.3. So in the question, you make a correction. 9. Yes. So what is the highest? Diamond 2.42. And smallest is air. Right. So you can just mention it. Highest optical density. So, a suggestion to all of you, don't be lazy, okay? Start writing the full thing. Don't keep things in head. It's going to get washed out. Just 2 classes or 2 days. So just keep writing. What is the highest optical density? What's the value? You have to just see and write from the calculator is 2.4. And lowest. 1.5, 1, just 1, 0.0003. So most of the times you take it as 1. Okay. You are given kerosene. Next question. Anybody else has the textbook? No. Yes. So read the next question, fourth one.
Given kerosene, turpentine and water, in
Yes.
which of these does the light travel fastest? Use the information given in table 9.3.
Yes. किसमें होगा पहले ये बताओ जिसका डेंसिटी ज्यादा है या जिसका डेंसिटी कम है कम में क्या होगा so in light travel fastest in the medium whose refractive index is least ऐसा लिखो so light will travel fastest बराबर ना because less resistance कम करेगा fastest in the medium with least refractive index ये याद रख लेना because refractive index तो फैक्टर बताता है ना जिसका ज्यादा होगा वहां पे स्पीड कम होगी कौन सा है सर वोट Hey, from the given तीन दिया है ना आपने वो क्या दिया है kerosene, turpentine and water. So water का कितना है देखो water, kerosene और क्या है turpentine. वाटर का कितना 1.33 केरोसिन का कितना
Kerosene 1.44.
केरोसिन is 1.44 और टर्पेंटाइन
1.27.
1.47 सो फास्टेस्ट किस में चलेगा वाटर लोएस्ट किस में जाएगा टर्पेंटाइन ठीक है इसमें मीडियम और इन बिटवीन समझ आ गया क्वेश्चन 5 कौन पढ़ेगा
The refractive index of diamond is 2.42. What is the meaning of this statement?
yes tell us please who wants to tell
So, in the diamond, the speed of
भाई पहला वाला क्वेश्चन पढ़ो इसके पहले वाला रिफ्रैक्टिव इंडेक्स और स्पीड
speed is the highest.
Yes, lowest. This statement means that light will travel lowest with lowest speed in
Diamond.
ये तो है और क्या पढ़ रहे हैं जिसका रिफ्रैक्टिव इंडेक्स ज्यादा उसमें लाइट की स्पीड कम रिवर्स रिलेशन इसका ये मतलब है सबको समझ आ गया
Yes, sir.
ठीक है ना रिफ्रैक्टिव इंडेक्स मतलब उसमें स्पीड ऑफ लाइट कम हो जाएगी जिसका ज्यादा रिफ्रैक्टिव इंडेक्स बस सो द हार्ड पार्ट इज ओवर अब कुछ है ही इस चैप्टर में कुछ भी डिफिकल्ट अब बचा नहीं है ये रिफ्रैक्टिव इंडेक्स ही हार्डेस्ट है समझने के लिए वो भी इसलिए क्योंकि फर्स्ट टाइम पढ़ रहे हो बाद में तो इट विल बिकम चल अब तो वही इमेज रेखा चित्र ठीक है सो लेट्स गो बैक टू रिफ्रैक्शन बाय स्फेरिकल लेंस सो पहले पढ़ते हैं लेट अस अंडरस्टैंड व्हाट इज लेंस So lens क्या होता है? So let's write down. It is a transparent medium. Medium. Bound by surfaces such that at least one of the surface is spherical. Spherical. Okay. So basically, what we are covering is spherical lens. Just like spherical mirrors, we have spherical lenses. And what is this? This is a lens. Okay. So, what are the two types of lenses we are going to learn? So, we have one like this. The other one is like this. Yeah. This is called biconvex or just convex. This is called concave. Okay. So how it is made is, then this is the center of the lens, and we call it optical center. In mirror, we had this as pole, but for lens, we call it as optical center. O is optical center. Okay. How this lens is made? Again, it is made out of two spheres. This time the spheres are not hollow. They are filled with glass, right? It's a solid glass sphere. And then what is done? So obviously it will have two centers, right? Mirrors had just one center because it was cut out of one hollow sphere. Here you have two spheres, and now it will have therefore two center of curvatures. Right? So which is the first surface? This is the first surface, left side. This is the second surface. So first surface the center किधर है? ये. ठीक है? So don't get into C1, C2 and all that. Just write C. Okay? उसका focus भी इधर बीच में आएगा. है ना? So lenses will have two focuses and two center of curvatures. Got it? In terms of numbers, this will be C1, F1. This will be C2, F2. Because surface का center, second surface. Got it?
Yes, sir.
और इसके केस में उल्टा हो जाएगा. C1 and F1 will be on the left side because this is the first sphere, right? First surface इधर ही रहेगा और इसका इस तरफ से हो जाएगा. ठीक है? So to avoid the confusion, we will drop this surface. We just say C and F. ठीक है? हाँ. Can I erase all this? We have let's study the image format. Okay, so next. So just like in case of concave mirror, there are 6 object positions. First is object at infinity. Object at infinity. Right. Now I told you in case of concave lens, convex lens, the images will form at the same position, okay, where it formed for concave mirror, right? So there will be 6 object position for convex lens. The principal axis will now extend on both sides because now it is a transparent medium. So what happens when the object is at infinity? It will receive a parallel, right? So here also you mark C and F, and C and F, same logic. So where will the parallel rays converge? At focus, is the focus. So incident ray on the front of the lens, refracted ray on the back of the lens, right? So where are the reflected rays converging? At focus. Now you can mark it. So wherever the refracted rays converge, it is called principal focus. Principal focus. Both in case of mirror as well as lenses, right? So this is the principal focus. So how it is happening? You understood? How many refractions are taking place here? 2. 1. Why 1? Rectangular glass slab. It has 2 surfaces. So 2 refractions. First surface and second. So how it is taking place? Look here. We will not draw it again and again. This is just once to explain the concept. See what happens is. So it comes here, right? Now where is the center of curvature for this? On the other side. So where is it? This is F. So what is the normal at this surface? Normal is line joining this point to C. Correct? What is the normal? Join this point with C. This is the normal. Right? So after refraction, what should happen? The rays should bend towards the normal because this is denser. Everybody pay attention here. This is air, this is glass, right? This is glass. So the ray will bend towards the normal. Right? Now you have C over here as well. So now you need a normal at this point. So join it with C. Now this ray will go away from the normal, right? So it goes away from the normal and therefore it goes from focus. Okay? It goes further away from the normal. The normal for this curvature is this line, the radius of this sphere. Okay? So it is bending twice, like this is not accurate diagram, but now it gives you the concept, the idea. So once the ray bends towards the normal, and then it bends away from the normal. So it bends twice in the same direction. That's why it is going from focus. Got the idea? But we don't say, show all these things over here. We just bring it till the center of the lens. And then we say it is going through focus. Is it clear?
Yes.
This is just the concept diagram for you to understand. It is shown in ICSE syllabus, but not in CBSE. So I just thought I'll explain you once. Clear? So I'll remove it now. So now tell me, what is the image position? Image at focus, yes. At principal focus, your focus just लिख दो. Principal, not required to write, so you can say focus. Okay. What is the nature? Real and inverted, because the refracted rays are meeting at a point. So it is real and inverted. What about size of the image? Highly diminished. Okay. So image is highly diminished. Can I erase this side? Yes, no, yes.
Yes.
So now it will be very smooth. So next parts now. Second is object at beyond. Okay. So we have. So again the steps. First you draw the lens. So it is kept vertical to principal axis. Then draw the principal axis. Then mark C and F. Both at equal distances on either side. The object will be beyond C. Name the object AB. Now, in case of lens, when the ray passes through the optical center, it will not deviate. It will go straight, right? Because anything which is passing through O is normal. See, from here, O, it will go straight. So what are the two rays we will take? We will take one parallel to principal axis, which after refraction will pass through focus. The same rules. One ray passes through focus. What about the other ray? Other ray we take from O itself. So where does it go? Okay. So it will pass and deviate. So where is the image formed between F and C? Is it different than it formed in case of concave mirror? No, it's the same position and nature. Only thing is it is now behind the mirror, right? This is A dash. So behind the mirror was virtual image, but behind the lens is real. This is the difference. all the real images are now forming
Yeah.
behind the lens. In case of mirror, it was in front of the lens, right? So this is behind. This is front. The image between F and C. Real and inverted. And it is diminished. Same way, right? The only difference is the image is forming behind the lens.
What will be the object that's
Yes. At C. Right? So you can now try yourself as well. So it will be same as concave mirror, object at C. So what should be the nature of image in this case? Same size. And where should be the image?
Behind the mirror.
Where? What position?
At C.
At C itself. Okay? Exactly. So draw the diagram. So you can start with the lens. So in the notebook, what you can do is where you want to position lens, you draw a straight line. Then you draw a principal axis line. This is how you draw. First straight line and then just make a, because you have to make use of compass, right? So once you draw from here, now keep it on the other side and draw again that way. So you have C. All those techniques I have already explained to you. C, F. So then you keep the object here. A, B. Right, so parallel will always pass through focus. Right. Next, you pass from this. So make sure that you cross this line, this point. All three dots should match. Wow. So right. So now you can see that this A dash, B dash is same as AB. So do the markings after drawing the ray diagrams. Otherwise, the line may go from above what you written, right? So just have the line and the dots, and then later on you label it. So what about image C? Real and inverted. Yes. Anybody having difficulty in understanding why real and inverted? Because these rays are meeting each other after refraction. In case of reflection, it was meeting after reflection. So for real image, the reflected or refracted ray has to meet. Okay? So it's meeting. That's fine. And whenever it is real, it has to be inverted also. Why inverted? This is the object here. How is the image? Upside down. Okay, that's why inverted. What about the size? This is same size. So, as the object approaches the lens from infinity towards it, the image size starting from highly diminished, the image size then starts growing bigger, okay, and starts going away from the focus, right? So initially at focus, now the image is shifting. You see, initially at focus, then between focus and C, now at C. So this is the pattern, which is same as it was in case of mirror session, right? So you might be observing same position, nature, and size as it was in case of concave mirror. Only difference is now it is happening on the opposite side of the lens. Shall we go for the next one? Next one will be between. So you came from infinity here, see, now see. Simple, right? The references are here. Fourth. Object between C and F. We have okay. So just the markings, complete the ray diagram, then only label. So now it will be between C and F. In place anywhere. This is AB. One ray parallel to principal axis. It will pass through focus after refraction. Right. It goes like this. Then the other one take through optical center. Let's see where it meets. It meets. So the direction has to be before the lens as well as after the lens. Before the lens is for incident ray. After the lens is for which ray? This direction is for incident ray. And this direction is for refracted ray.
Refracted ray would go back, right?
Why it would go back?
Because it will retrace its path as it is passing.
Where is it getting? Where is the direction change?
Because at O it will retrace its path.
Is it reflection or refraction? Transmission is happening. No? So where is the opportunity for it to retrace its path? There's no opportunity, no? So there should be some opportunity, right? This is transparent medium, not reflection. Okay. So it will not deviate. You will say it will not deviate. It will follow the same path
It
ahead.
will just trace it. It will not retrace its path. It will just pass through the optics.
Yes, it will pass through the optical center undeviated, without bending. Without bending. So when the ray is along the normal, in case of lens, it will pass without any bending. Clear? So now, so the situation, in different situation, like when the stick was inside the water, that time the ray was coming out, and then backward was the, when we extended backward, the diverging ray. Right now there is no divergence. So convergence happens. Okay. Good. So where is the image forming now? Beyond? Beyond C. Yes, it is real. So why are you not confident? I mean, why there is doubt? And why you need validation? You should be confident. Yes, क्योंकि क्यों? ये दोनों मिल रहा है ना? दोनों मिल रहा है. तो क्या होगा? Real and inverted. ठीक है? चलो. So we have A dash, B dash. दिख रहा है अपने को, मिल रहा है. And it is magnified also. तो अभी क्या बनेगा देखो? Beyond C. So you can also say behind the lens and all, not required to. क्योंकि refraction के केस में other side ही हो. Then real and inverted. Then magnified or enlarged. ठीक है? या तो enlarged लिखो या फिर magnified. Okay. चलो फिफ्थ वाला बनाओ. क्या होगा ऑब्जेक्ट क्रिएशन? यस. आगे सब लोग बनाओ. आई विल कम एंड चेक. So where is the object at? What are the here? Correct.
Sir,
Highly. It's not.
sir,
Yes. Yes.
I didn't know that.
Sit. On error.
All right.
What's the nature? Position, nature, size. Diagrams, right? So most of you are getting the diagram right. I'll also draw it. How did your ray travel back? Is it a transparent medium or reflecting medium? Transparent. So how will it come back? Then we go ahead, right? Then like this. So you're getting a parallel ray. Infinity में जाके मिलेगा. So basically, image कहाँ बनेगी? At infinity. So this case is opposite of first case, right? When the object at infinity, image at f. When the object at f, then the image at infinity. Reverse. Real and inverted. Yes. Yes, it is highly magnified or enlarged. So next one we try karo. Next object position is between F and O. So everybody draw for yourself. Yes. Anybody has difficulty in this part?
You wrote here and remote, but the rays are not meeting.
Yes. Where does the parallel rays meet? Maths में क्या पढ़ा है? At infinity, it is meeting at infinity, right? That's what we say, right? It is meeting at infinity. Go check for yourself. You got the last one?
Yeah.
Nice. Okay. Yeah, let me check the arrows. Correct. Okay. Perfect. So when we just say F, right? Do we get an idea whether it is behind the mirror or in front of the mirror? But when we say F1, when we write this, then it is behind, right? So you can make that change. If you want, you can write it is behind. Like C is, he has written it very correct. So C is 2F. And which 2F? 2F1. See, for example, you can write this as F2, C2, right? This is F1, C1 or 2F1, right? C can be written as 2 times F. Okay. So don't get confused. In your book, it might be given C1, 2F1. So accordingly, if you write the number, you actually know what is the position. It is behind the fence. So see for yourself, like how you want to do. What about this? I suggest you mention 1, 2. Okay. In all the position, image positions where we have written just F, make it F1. Okay. So that will actually remove any scope of confusion. So this is C2, F2. And this will be F1, C1. Chalo. कैसे बनेगा इसका diagram? Where is the object between F and O? So obviously one will be parallel and it will pass through F1. Here. Second will pass through O. How is the nature of rays? Is it likely to meet anywhere?
Yes.
Yes.
Meaning when we extend them backwards.
So but the refracted ray is not meeting because it is diverging now. So then we have to imagine that these are meeting somewhere in front of lens. See, now the virtual image will form here. Okay, so this AV Z dash. Understood? It is reverse of concave mirror case. So what is the image position? Image in front of lens. So if it is in front, then it has to be virtual. We don't say between C2 FT or not. We will not say that. We'll just say front of lens. Because when it is from here to here, anyway, so virtual and direct. What about the sides and last? So this is the principle on which magnifying glass works. When you read like small letters, okay? So you keep the object very close to the lens between F and O. Then you see magnified image. This is the principle. Right. It is also called as simple microscope. Simple microscope or magnifying glass. Okay. So what is the application of this? Application of keeping the object between focus and optical center is magnifying glass. Or simple microscope. Right? Then you have compound microscope. Simple because we are using only one lens. In compound, you will use two lenses. Okay, combination of that. So that's why you're compounding the effect of magnification many times. With one lens, you can magnify it 9 or 10 times. With two, 10 into 10, hundreds of times. Then it becomes compound microscope. The one that we use in the lab, etc., is a compound microscope. Okay, so with this, we have completed. Everybody is clear with 1, 2 difference?
Yes, sir.
One is behind, two is in front for convex lens, and opposite for concave lens. So all the image position summary is given in the textbook. These are 6 line items, and you can quickly revise. It must be in volume also.
Yes.
What page of volume? Do you have the summary given?
Not the summary, but
They have given in terms of diagrams, I think.
yeah.
Okay. So in textbook, you have given, you are provided with the summary of all the image formation. It is on page 152 in the new textbook. Okay. And in the textbook, they have mentioned in terms of F1, F2 and all that. And when you have 2 F2, right, or 2 F1, it means C. Twice of F is C. Remember that. Okay. All right. So any questions regarding image formation by convex lens?
So
This is 6. 1 second. Huh? This is 6. Bolo. For what?
for object between x and
It's okay, but it is, as long as it is in front of the lens, it's fine. That's why there is only, it is mentioned in front of the lens. It is written on the same side of the lens as the object. Okay, you can write either in front of the lens or same side of the lens as the object. ठीक है, so ये हो गया तुम्हारा image formation by convex lens. Let's quickly do image formation by concave lens. So how many object position for image formation by concave lens? Only 2. Like it was for case of convex mirror.
Yeah.
Same thing. Let's do that. concave mirror lens. So let's draw the concave lens. Now you know how the concave lens is to be drawn. Let's say a question comes, differentiate between convex and concave lens. What will you write?
Concave is diverging. And
That's the other name for concave lens. And convex is converging lens. Okay, this is one difference. Second difference, in terms of thickness, right? Convex is thicker in the middle, thinner at the edges.
So the image formation went from convex, right? Convex mirror is behind the mirror. Such of convex lens is behind the lens, and in concave mirror is concave lens.
For what kind of images?
So then concave only forms the
All behind the lens will be all real images. Okay, in front of the lens will be virtual. So this is how you.
Okay.
Okay.
concave lenses are positive power. Lenses are negative.
Ulta होगा. Whose focal length is positive? Convex focal length is positive. So let me cover power first. You don't jump till power. Power we have not completed yet. School में हो गया क्या? इसलिए माइंड द्वारा स्विच. Power अभी मैंने यहाँ पे complete नहीं किया. So wait till then. What did you say? Convex lens positive है कि? Convex positive है ना? Focal length क्या है convex का? Positive है. अभी मैं sign convention cover करूँगा. तब clear हो गया.
ये होता है ना, right? ये कार्टेशियन क्षेत्र राइट में पॉजिटिव लेफ्ट में.
तो इसका फोकस कहाँ पे है? इस तरफ है ना? प्रिंसिपल फोकस इसका किधर है? इधर है. पॉजिटिव है तो पावर भी पॉजिटिव होगा इसकी. समझ गए? मैं समझाऊंगा. एक्चुअली स्कूल में जिस तरह से पढ़ाते हैं ना वो तुमको मेमोराइज करना पड़ता है. इससे सिर दुखता है. हम लोग जिस तरह से पढ़ाते हैं वो तुम्हारे पर्सनैलिटी का पार्ट हो गया. ठीक है? तो कार्टेशियन का सिस्टम तो ठीक है, लेकिन कहाँ पे प्रिंसिपल फोकस क्या होता है? जहां पे पैरेलल रेस कन्वर्ज होती है वो प्रिंसिपल फोकस होता है. उसके हिसाब से फोकस डिसाइड होता है. तो कॉन्वेक्स का फोकस हमेशा पॉजिटिव होगा. ओके, सो लेट मी कवर द साइन कन्वेंशन. हाँ, वी वर डिस्कसिंग डिफरेंसेस इन कॉन्वेक्स एंड कॉन्केव. चलो दो डिफरेंस बताओ. तीन डिफरेंस बताओ. पहला क्या है? पहला स्टेट से बताओ. कॉन्वेक्स में थिकर इन द मिडिल, थिनर एट द एजेस. कॉन्केव में this is one difference, physical difference. Second difference,
Convex mirror is a real lens. Convex lens is a real
image formed
formation
by convex. तो उसको सिर्फ बोलो converging, क्योंकि वो क्या करते हैं? It is converging lens and this one is diverging. ये दूसरा हो गया. ठीक है. अब कितने टाइप की इमेज बन सकती है इसमें? All real as well as virtual, diminished as well as magnified images can be formed in convex lens. ठीक है. हर टाइप का इमेज बनता है किसमें? convex lens. concave में क्या बनेगा? only virtual and diminished. enlarged बनेगा ही नहीं. जैसा concave, जैसा convex mirror में हुआ, कैसा हुआ था? magnified नहीं था. It was always diminished. ठीक है. तो यहाँ पे वो किसमें होगा? कॉन्केव लेंस में होगा. ऐसा उल्टा है. लेट्स ड्रॉ द रे डायग्राम्स. तो फर्स्ट इज ऑब्जेक्ट कहाँ पे होगा? ऑब्जेक्ट एट इंफिनिटी. ठीक है. तो ये लेंस हो गया, प्रिंसिपल एक्सिस हो गई. लेट्स राइट इट विथ. अब इसका फर्स्ट सरफेस का कर्वेचर किधर है? इधर ही है. तो इन दिस केस F1 and C1 will be on the left side. फ्रंट में होगा. याद रखना दोनों के लिए अलग है. हाँ, कॉन्वेक्स में ये F2 और C2 होता है. क्यों? क्योंकि फर्स्ट सरफेस का इधर है और यहाँ पे किसका कर्वेचर है? सेकंड सरफेस. ठीक है। अब ये सेकंड सरफेस का है तो ये हो जाएगा F2 और ये हो जाएगा C2। या तो तुम इसको 2F1 भी लिख सकते हो और 2F1 और 2F2, समझ आया? आइदर C2 और 2F2 कुछ भी लिख सकते हो, ठीक है। तो अब देखो, अब तुम्हारा कहां से आ रहा है? इंफिनिटी से सेंटर तक लो, सेंटर वाली जो डॉटेड लाइन है लेंस की वहां तक लो, ठीक है। तो ये तुम्हारा हो गया यहाँ तक। तो इंसिडेंट रे का डायरेक्शन डाल दिया। अब क्या होगा? कॉन्वेक्स में क्या था? पैरेलल रे कन्वर्ज एट फोकस। ये क्या होगा? इट विल डिफ्लेक्ट अवे फ्रॉम फोकस। तो फोकस क्या है? ये, ठीक है। So when you extend backwards, it meets at focus. When you extend it backwards. समझ आ गया? So when you extend backward, it meets at focus. So image at F1, right? अब देखो, अब इसमें F1 करते हैं तो कॉन्वेक्स में भी F1 पे था, लेकिन कॉन्वेक्स का F1 कहाँ था? बिहाइंड लेंस था। और कॉनकेव का F1 कहाँ है? फ्रंट है। तो इसमें समझ नहीं आती चीज अगर सिर्फ इमेज एट F1 लिखोगे, ठीक है ना। तो अब लेकिन यू नो सिंस इट इज इन फ्रंट लिख दो। फ्रंट में क्या बनेगा यहाँ पे? वर्चुअल। C2 के नीचे या तो C2 लिखो या 2F2 लिखो, या C1 लिखो या 2F1 लिखो। तुम अपने टेक्स्ट बुक में देखो F1 F2 ऐसे दिया हुआ, क्योंकि C2 ट्वाइस का डिस्टेंस है ना। ये देखो, O से C2 का डिस्टेंस क्या है? ट्वाइस ऑफ F2 है ना, इसलिए 2F2, 2 टाइम्स। So this is or either write C2, look here, either write C2 or 2F, ठीक है। और यहाँ पे जस्ट C और F चलेगा, दोनों साइड, दोनों का वैल्यू सेम ही, एक फ्रंट में और दूसरा बिहाइंड। साइज बताओ, साइज साइज क्या है इसका, इमेज का? हाईली डिमिनिश्ड, क्योंकि डिमिनिश्ड टू अ पॉइंट है ना। ऑब्जेक्ट साइज क्या है? वी डोंट नो, वेरी बिग, इंफिनिटी पे, बट दिस इज पॉइंट, सो हाईली डिमिनिश्ड। Okay, so now with this we come to the last ray diagram. सबको समझ में आया ना कॉन्वेक्स रे में क्या हो रहा है? यस सर, पैरेलल रेज को अवे फ्रॉम फोकस। कॉन्वेक्स में क्या होता है? दे गो टुवर्ड्स फोकस, ठीक है, इसमें अवे फ्रॉम फोकस। नाउ तो अब यहां से भी ऑब्जर्वर देख रहा, तो ये डाइवर्जिंग रे है, मतलब कहीं से तो आ रहा होगा, यहां से आ रहा है, इसके लिए एक्सटेंड करें, ठीक है। खाली किस कौन से टाइप के रे को एक्सटेंड बैकवर्ड करते हैं? जो डाइवर्ज हो रही है, जो कन्वर्ज हो रही है वो तो मिल ही जाएगी। वहां पे क्या बनेगा? कौन से टाइप का इमेज बनेगा? जहां कन्वर्ज हो रही है रियल एंड इन्वर्टेड, और जो डाइवर्ज हो रही है, कहां से डाइवर्ज हो रही है, वहां पे कौन से टाइप का इमेज बनेगा? ठीक है, बस यही फंडा है, चाहे मिरर हो या लेंस। नेक्स्ट, अब बताओ ऑब्जेक्ट पोजीशन क्या बनेगी? एंड ऑप्टिकल सेंटर। इंफिनिटी एंड O, ठीक है, तो ये बन गया। Okay. So here we are the mother to where for. कहीं पे भी ले लो, लेट्स से हमने इसको यहाँ पे रखा, सबसे पहले इसको कहाँ पे लेके आएंगे, सेंटर ऑफ द लेंस पे लेके आएंगे पैरेलल.
So 2s can be also written as P, right?
Yes. ठीक है. So अब इसका क्या होगा, it will go away from the focus. ठीक है, तो उसको एक्सटेंड करके पीछे ले आएंगे बाद में. दूसरा कहाँ से आएगा, ओ से आएगा. Now, so here it is going undeviated, but when somebody observes from here these two rays, what will appear to him? That from where it is coming to him from. Got it? So we don't say show the ray backward, not here, because it is transparent. But then he feels these two rays actually meet here, and this ray is extended backward. Okay. So now this is the image position. So image is formed in front of the lens between F and O. It will always be between F and O, F and towards O. Okay. So you can try for any ray, it will always be between F and O. So image between F1 and O. Nature is virtual and direct. And size is, who is saying highly diminished? Not highly diminished. Highly diminished तो ये था जो point है. अब इससे ज़्यादा diminish हो रहा है क्या? इसके बाद क्या हो रहा है? बढ़ रहा है. So it is diminished. बढ़ रहा है but फिर भी object के बराबर नहीं है. So this is your A dash, B dash. It is just diminished. Okay. So with this, we are through with image formation in case of convex and concave lens. Okay. So now what is remaining? We have how many more minutes? 10 minutes. 8 minutes. Yes. You guys are very precise. Okay. So let's see what else we can do. We can cover the sign convention for lenses. So any questions still here? Good. Do we have uses of convex and concave lens. Differences I already told you. We have to study. Right. Next is sign convention. I just gave 2-3 times. What 2 points you have written?
First one that.
The physical difference. Thicker in the middle.
Real and virtual.
Real virtual in case of
Real virtual in case of convex and.
Only virtual?
In case of convex.
so only virtual and smaller size. Diminished in concave, and for convex it is all types. All types. Okay. Third is it is called as converging lens. Convex, and it is called as diverging lens. In terms of power, convex lens has positive power and diverging lens has negative power. That is the fourth difference. All right, let's now discuss the sign convention in case of lenses. Okay. Now you see, you have, these lengths, right? This is object distance. What is object distance? Distance of object from O, right? Then what is the image distance? Distance of image from O. Its symbol is V. And what is the focal length? This is the focal length. Distance of focus from O. Okay, so these distances you must remember. What is the symbol U means, B means, and F. Okay. Now, so sign convention for lenses. Okay. It is the Cartesian sign convention. Somebody asked me about sign convention. I think who asked the sign convention? So pay attention here. It is same as your Cartesian sign convention. So in Cartesian, you have this as x-axis, x dash, y and y dash. So the intersection, the origin in this case is optical segment. Okay, silence. No, cut it. Who is that? Right. So this y-axis for us is all the lengths above the principal axis or above O. Okay. Y dash is below O or below principal axis. Okay. So x dash axis principal axis for us. So we don't write x and it is just principal axis for us. Okay. So this is your principal axis. Principal axis. So what is the thing to be kept in mind? All distances are measured from O. So all distances or all lengths are measured from O. What is O here? Optical segment. Okay. So the distances to the left are negative, to the right are positive, above are positive on both sides, below are negative on both sides. That's it. This is the sign convention. So now let us write it for concave and convex lens. So first sign convention. So let's write convex lens, and here we'll write concave lens. Lens, whether you don't have E in the last. So first is object distance. So first start with focus, focal length. U. So what is the sign of U? Always negative. Okay? U is always negative, irrespective of the length. Okay? Then you have object distance. You write instead of length, you write distance. Distances. Oh, sorry. F. Focal length is F. Correct. Object distance is U. So for convex lens, change it. Always positive. Concave is negative. Make a correction. Only one person observed it. Huh? Everybody was just writing it like focal length F is positive or convex. Which focal length to be taken? Principal focus. So for convex lens, all the parallel rays converge on the right side. So that's why positive. Okay. For concave lens, all the rays diverge. So they are taken on the left side. Okay. So the principal focus for concave lens is in front of it. That is why. Okay, so sign convention we had just started. Anyway, for object distance, you know that it is always on the left. So negative. And what is last? F, U, and V. What of V is image distance.
They will be negative and positive.
Real के लिए क्या होगा?
Negative.
Positive. Real is on the other side, behind.
Acha, height will be negative.
Height will be correct. This is horizontal distance. So this is positive for real, negative for virtual. Okay? ऐसे लिखना. Concave lens में तो सब क्या होता है? Negative होगा. Since virtual. ठीक है? तो अब क्या बचा इसमें और कुछ बचे? मैग्निफिकेशन बच गया. मैग्निफिकेशन देखो ये बाद में करेंगे. मैग्निफिकेशन H and H flat. ठीक है? तो ये नेक्स्ट क्लास में बताओ. H and H dash. Height of object and height of image. ठीक है? मैं करवा सकता हूँ अगर 2 मिनट हो गए तो. लिख दो साइंस. लिख देते हैं. वो एक ही बार में खत्म हो जाएगा. नहीं तो फिर बताओ मैग्निफिकेशन रियल के लिए क्या होगा? नेगेटिव. ठीक है. वर्चुअल के लिए क्या होता है? पॉजिटिव. ये चीज ध्यान रखना. ये मिरर में और लेंस में सेम है. ठीक है? सेम दिस आल्सो. यहाँ पे तो रियल ही है तो नेगेटिव. सॉरी वर्चुअल ही है ना उसमें. वर्चुअल में पॉजिटिव. ठीक है. हाइट पॉजिटिव. यहाँ पे भी पॉजिटिव. इमेज
negative.
नेगेटिव फॉर रियल. पॉजिटिव फॉर यहाँ पे क्या है पॉजिटिव चलो
So form is L.
this is it
So what is the form of H? H form.
objects अच्छा चलो ठीक है ये मैग्निफिकेशन object height you can write height or size object image ठीक है so if you have this clear now you cannot go wrong while solving numericals ठीक है I have given you all the possibilities चलो see you next week bye